Hey, what's up, Mr. Sutter here. Today we're going to be talking about static electricity. Let's get started. So what is static electricity? Static electricity is the buildup of an electrical charge on the surface of an object. This charge builds up, but it does not flow. Static electricity is electrical potential energy. It doesn't move. It is stored electrical energy that is built up on the surface of material. In this case, we have a cat on the left with a static electric charge on it, which is causing those packing peanuts to stick to the cat's fur. Right, so we're going to need this in a second, so we're going to do a quick rehash of atoms. Right, so atoms contain charged particles. All matter, again, is made up of atoms. There are three pieces that make up an atom. We have protons with a positive charge that are in the nucleus. We have neutrons that are neutral that are also reside in the nucleus. And then we have electrons which have a negative charge which are in the electron cloud outside of the nucleus. Right, so where do charges come from? Electrons. Electrons are located on the outer edges of atoms, and they can be moved. Protons and the neutrons don't move, it is only the electrons that move. So a concentration of electrons in an atom creates a negative charge. So if you have more electrons, you have a negative charge. If electrons are stripped away, the atom becomes positively charged. So in short, if you gain electrons, the object becomes negative, and if the object loses electrons, it becomes positive. So gaining electrons, more negative charge, so overall negative, and losing electrons, less negative, so overall positive. Right, let's look at static discharge. So static discharge is that shock that you might be familiar with. So static discharge occurs when there is a loss of static electricity due to three possible things. Friction, either from two objects rubbing back and forth against each other. Conduction through direct contact, that's like when you touch the doorknob and then you get a little shock on your finger. Or induction through an electrical field, not direct contact. That's like if you take a sweater out of a dryer and when you go to put it on, your hair stands all up. That's also static discharge through induction. Even if you put the object that's statically charged near your head, it's going to raise your hair even though it's not touching. Right, so how is a static charge generated? When two objects rub up against each other, electrons transfer and build up on one object, causing it to have a different charge than its surroundings. So like shoes rubbing against the carpet, electrons are transferred from the carpet to the shoes. So let's take a look at that. So on the left, before rubbing, both the shoe and the carpet have an equal number of protons and electrons. They're shown there by pluses and minuses. Now, however, after rubbing, some of the electrons from the carpet have now moved to the shoe. So now the shoe on the right has a negative charge because it has more electrons, and the carpet has a positive charge because it has less electrons now. So now the shoe on the right is electrically charged and it has a negative overall charge. Right, so what causes you to be shocked when you rub your feet across the carpet? Right, so again, as we just looked at, as you walk across the carpet, your body builds up a static charge. When you reach for a metal doorknob, the charges flow between your hand and the doorknob, and you feel a shock. So you have a negative charge on you from picking up those extra electrons off the floor, but those negative electrons, they don't want to be on you. They want to get away as fast as possible. They want to find a neutral source. So when you put your finger near the doorknob, the electrons jump off your hand to the doorknob, and that's the shock that you feel, is the electrons jumping off your hand, right? So an electrical discharge is the passing of an electric current through the air from a negatively charged object to a positively charged object. This is also what causes lightning. So on a very small scale, when you put your finger near the doorknob and you get the little shock, that's the same thing that's happening when we get lightning, except on lightning, it's a much, much larger scale between the ground and the upper atmosphere in the clouds. All right, now let's look at conductors versus insulators. So conductors are materials that allow electrons to flow through them easily. Insulators are materials that do not allow electrons to flow through them easily. So conductors conduct electricity. Electricity moves through a conductor very well. And insulators do not conduct electricity. Insulators do not allow electricity to flow through them. All right, so here's some examples of conductors and insulators. So for conductors, all metals are conductors. So for example, some metals that are good conductors of electricity include aluminum, copper, gold, and steel. Water is also a good conductor. Some liquids can be conductors. All right, now we have some examples of insulators. Some insulators include styrofoam, rubber, plastic, paper, and glass. All these insulators are materials that electricity does not want to flow through. Let's look at attraction and repulsion. So attraction is the act of two bodies, we call those objects, drawing toward each other due to opposite charges. Repulsion is the act of two bodies moving apart from each other because they have the same or like charges. Right, so let's take a look at this visually. Right, so attraction, the act of two bodies drawing towards each other because they have opposite charges. So negative, negative, that's the same. Positive, positive, that's the same. Neutral, there's no charges. Oh, here we go. Here we have two bodies with opposite charges. So there's a positive and a negative, and when a positive and a negative come near each other, they attract each other and they move closer together. So if they have opposite charges, they attract and move close together. Right? Repulsion, the act of two bodies moving apart from each other because they have like charges. So if I have a negative and I bring them close together, they're going to repel and push away from each other. If I have a positive and I bring them together, they're going to repel each other, right? So like charges repel, so negative and a negative repel, positive and a positive repel. So attraction, again, they're bringing together. If they have opposite charges, positive and negative attract. Repulsion, two things moving apart. Negative and a negative repel and push apart. Positive and a positive repel and push apart. One last note here. Neutral objects, so those green circles, which are neutral objects do not have a charge. The positive charges, or changes there, the positive charges balance out with the negative charges on the object. So they don't attract or repel each other. The neutral objects simply sit there because they do not have any net charges on them. All right, one last thing here. All right, so we're going to look at that balloon sticking to the wall trick. So in this first set, we have a person and a balloon, and they are both electrically neutral. Neither the person or the balloon is positive or negative. As the person rubs the balloon on their hair, electrons move from the person's hair to the balloon. This gives the balloon a negative charge, right? So the person went from being neutral, and the balloon went from being neutral to now the person gave the balloon a negative charge by transferring some electrons from the hair to the balloon. So the balloon has a negative charge now. Right? So when this negatively charged balloon is placed on the wall, it sticks to the neutral wall. Electrons in the wall move away from the electrons in the balloon, right? Remember, negative and negative repel. So the electrons in the wall try to move as far away as they can from the negative electrons in the balloon. And then due to attraction, the negative charges, the negative electrons in the balloon, attract to the positive protons in the wall, which causes the balloon to stick, quote unquote, to the wall. Now, the balloon will stick to the wall, and this will continue to occur until the balloon loses enough electrons to the surrounding air that the force of attraction isn't strong enough to hold the balloon to the wall anymore. All right, that's going to wrap it up for static electricity. Thanks for watching. I hope you learned something, and I'll see you in the next video.